Hey everyone, and welcome to this explainer. We are jumping right into something absolutely fascinating today. We're going to explore how simply using cold temperatures might literally be the key to unlocking and healing complex metabolic issues. For anyone who has been struggling with their metabolism, the science we're unpacking today is a real game changer. We're going to look at the exact biological pathways where cooling flips the switch on a highly specialized tissue in your body, brown fat, and how waking it up can fundamentally transform your metabolic health.
So can being cold actually heal your metabolism? It's a pretty provocative question, isn't it? So many of us deal with things like metabolic syndrome, insulin resistance, or just that incredibly stubborn abdominal fat. And it often feels like you're fighting an uphill battle where all the standard advice just isn't working. But what if the missing piece of the puzzle isn't just about what's on your plate or how many miles you run, but rather the temperature of the room you're sitting in? The data we're diving into today gives us some seriously compelling, science-backed answers that might just make you appreciate a chilly day.
Okay, let's dive right into section 1. Not all fat is equal. Storage versus furnace.
To really get this, we have to completely shift how we think about body fat. Because for decades, right, fat has just been painted as the ultimate bad guy. But the reality is, not all fat is created equal. We've basically got two wildly different tissues at play here. On one hand, we have white adipose tissue, or WAT. This is the fat we're all pretty familiar with. Its main gig is basically acting like a long-term storage unit, packing away extra calories just in case. But then, on the other hand, we have brown adipose tissue, or BAT. This tissue isn't a storage unit at all. It's a furnace. It literally gets its brown color from being packed with iron-rich mitochondria. So while white fat hoards energy, brown fat is highly active, and it is specifically designed to burn energy and release it.
And the way brown fat pulls this off is through an incredible biological process called non-shivering thermogenesis. Deep inside those iron-rich mitochondria is this very unique protein called uncoupling protein 1, or UCP1 for short. When UCP1 gets activated, it essentially short-circuits the normal energy production of the cell. Instead of making usable cellular energy, it grabs vast amounts of chemical energy. We're talking about the fat and glucose just floating around in your bloodstream, and it dissipates it directly into heat. It is quite literally a built-in energy incinerator. Moving on to section 2, cold, the ultimate on switch. So we all have this amazing furnace built right into our biology. The obvious question then is, how on earth do we turn it on? Well, it turns out our bodies are highly attuned to our environment. The absolute best trigger to wake up that dormant brown fat is cold. But, and this is crucial, it's mild cold. The scientific literature consistently points to a very specific, totally manageable range, 14 to 17 degrees Celsius. That's about 57 to 63 degrees Fahrenheit. So honestly, the next time somebody complains about the AC being too high at the office, you can just tell them you're doing metabolic therapy. You absolutely do not need to be shivering in a miserable ice bath to get this machinery going. Just a mild chill does the trick. So how does a chilly room transform into cellular heat? Well, it's a brilliant little chain reaction. First, the temp drops, and the receptors right there on your skin sense the cold. Second, those receptors shoot a signal to your brain, which tells your sympathetic nervous system to release a neurotransmitter called norepinephrine directly into your brown fat. Third, that norepinephrine binds to the brown fat cells, waking up that special UCP1 protein we just talked about. And finally, boom, the furnace kicks on. It starts aggressively pulling in triglycerides and glucose from your blood to burn as heat. Now, if you're wondering where all this magic happens in your own body, researchers over at the UCLA School of Medicine actually mapped it out. By dissecting human cadavers, they physically traced the sympathetic nerve branches connecting straight to the brown fat depots. And these are mostly clustered right around your collarbone and neck area. This isn't just theory, it is hardwired into your anatomy right now. We all have this wiring, just waiting for the signal to activate. Just to put into perspective how powerful this tissue actually is, check out this staggering stat from the research. A mere 50 grams of activated brown fat, that is less than 2 ounces of tissue, could account for up to 20% of a person's basal metabolic energy expenditure. 20%! Because it burns through fuel so rapidly, active brown fat acts like this massive metabolic sink, just flushing circulating glucose and lipids right out of your system. Which brings us to section 3, combating metabolic syndrome. It's one thing to understand the biology, but what does this mean for real people, especially anyone dealing with obesity or metabolic dysfunction? Well, if you've been struggling in this area, you really need to know about a concept called brown fat resistance. You see, in folks with metabolic syndrome, the body's natural brown fat response is actually blunted. Why? Because that expanded visceral fat, the deep belly fat, creates this state of chronic low-grade inflammation. And that inflammatory environment actively suppresses the signals trying to turn on your brown fat. It essentially unplugs the furnace entirely. It makes so much sense, right? It elegantly explains why traditional weight loss can be so painfully slow for some people. Their inner metabolic machinery is literally being shut down.
But here's the really good news. When we use controlled cooling to break through that resistance, it directly reverses the core defects of metabolic syndrome. For abdominal obesity, cooling forces the body to mobilize that visceral fat to fuel the fire, while ramping up UCP1. For insulin resistance, it boosts glucose transporters, wildly increasing how fast your body clears glucose from the blood. And for dyslipidemia, it completely enhances the clearance of triglycerides, because your brown fat is actively pulling those lipids out of the bloodstream to replenish its own energy stores.
So what does this energy burn look like in the real world? Well, a major systematic review of clinical trials found that acute cold exposure, again, right around that 16 to 19 degrees Celsius mark, cranked up daily energy expenditure by about 188 kilocalories. Now, 188 calories might not sound like thousands, but think about it. A consistent daily boost to your basal metabolic rate of nearly 200 calories, that is a massive driver of negative energy balance over time.
And the benefits go so far beyond just burning extra calories. Just look at the clinical results for patients with type 2 diabetes. After following a simple 10-day structured protocol of mild cold acclimation, hovering around 14 to 15 degrees Celsius, these patients saw their peripheral insulin sensitivity shoot up by roughly 43%. That is a profound improvement in the body's ability to manage blood sugar, happening in less than 2 weeks purely from tweaking the thermostat.
Finally, let's look at Section 4, the future of cooling therapy.
So how do we bring this out of the lab and into our everyday lives? The future of brown fat activation is incredibly practical. First off, it's as simple as mild environmental adjustments, like deliberately keeping your living or workspace between 14 and 17 degrees Celsius. Second, researchers are designing specific 10-day cold acclimation protocols to help our bodies gently adapt and build up this tissue over time. Third, there's some really cool development happening with targeted home-based cooling vests, making the whole process super convenient. And maybe most exciting, scientists are looking into combining cooling with GLP-1 medications like Ozempic or Wegovy, which studies suggest might indirectly boost brown fat activity through the brain.
So I want to leave you with this final thought. Are you ready to embrace the cold to unlock your metabolic flexibility? Just by rethinking our daily relationship with temperature, we can tap into this primal evolutionary mechanism that is quite literally built to keep us metabolically active and healthy. You already have the furnace inside you. You might just need to turn down the thermostat to finally switch it on. Thanks so much for joining me for this explainer, and definitely keep exploring the amazing science of your own body.